Okay, so we're going to start. Welcome, everyone. My name is Scott Osborne, and I am the president of the Royal United Services Institute of Vancouver Island here in Victoria. And today we're welcoming Commander, retired, Doug Bancroft, President and Chief Executive Officer of the Canadian Scientific Submersible Facility, or CSSF for short. Now, today, Doug is going to give us a look at the technology of remotely operated vehicles, or ROV submersibles. Specifically, he's going to talk about the star asset of the Scientific Submersible Facility, the remotely operated platform for ocean science, or ROPOS for short. And the picture on your screen is of ROPOS. So Doug is going to talk for 45 minutes. Then I'm going to pose some questions to see if we can expand on his talk, followed by questions from you, the audience. So please write your questions on the Zoom chat or Q&A features at the bottom of the screen and make them brief. We end no later than 2:30 p.m. today. We're recording this talk and it'll be posted to our website ASAP. And I'll send out an email to everybody when it's on the website. So thanks, Doug, for taking the time to talk to us today. And if you're ready to begin, go.
Former Navy, ready, I ready. Thanks for the invitation. Thanks for those who are online and showing up for the talk. To put things in context before I get going, that robot submarine ROPOS that you see on the first slide is approximately 3.5 tons. And think of it as the size of a large Econoline 350 Ford van. It typically will deploy on a cable, which I not jokingly refer to as a string. That string you see in the photograph there is almost $500,000. And I'll explain why the strings are expensive. Everything we do is expensive. There. Okay, we do science, and we've been doing science for almost 3 decades. Prior to that, some of our team members have been doing it for almost 40 years. But every now and then, the government of Canada bumps into problems that they can't solve through either the Royal Canadian Navy, the Coast Guard, or contracting. And so on 3 occasions in our history, the government has reached back to us and said, can you solve something for us? And as a former naval officer interested in seabed intervention, it's something that I find is almost as much fun as the science of which I'm passionate about. So this is the outline of what we're going to talk about. We're going to talk about who we are as an organization, what that beautiful robot ROPOS does and how it does it so well. We're going to talk about other ROVs that we operate, and we're going to talk about 3 incidents that took place: a CF-18 recovery, Queen of the North, black box recovery, and a Coast Guard helicopter in the Arctic recovery. And then I'm going to talk about the future and where the future might bring us in terms of platforms for operating ROPOS, including the new class of the Harry DeWolf Arctic and Offshore Patrol Ships in the Royal Canadian Navy, plus 2 more that are being built after those are procured for the Canadian Coast Guard. And then we'll wrap it up in 45 minutes or less. So we were established as a not-for-profit in 1995. And some of us are old enough to remember that that was just after the country almost went bankrupt. Countries can go bankrupt. And they do. New Zealand, Iceland, France on several occasions. And we came up to the precipice and the government said, we can't go there. And so they slashed government departmental spending. The Department of Fisheries and Oceans at that time was operating both manned and unmanned robot submersibles. And they basically were going to put everything into Crown Assets and Disposal. They could no longer afford to do discovery science. They had to focus entirely on missions associated with operations, including fisheries management. So a group of academics got together and said, well, we could operate one of those, the unmanned one. And so they asked the minister if they could establish a not-for-profit and acquire these assets for $1. And that's what happened. And since then, we've been managing that particular ROV and upgrading it along the way, and other systems for other academics. And we are also expanding into autonomous underwater vehicle operations, which are the ones that don't get connected by a string, and maintenance for the various platforms that are used by academics and DFO that we don't operate directly, including DFO's drop cameras and things on the West Coast. We are a very small corporation. We have one full-time employee. All the others, including myself as the CEO, to the people who are operating the systems on the ships, are contracted in for the time they are available. And that's because if we're not lean, we won't survive. This is an expensive game to be in. Equipment is very specialized if you're going down to 5,000 meters. Recapitalization costs have to be done. Maintenance is important. So we are a very lean organization, but nimble enough to have survived. Our bread and butter is what they call benthic science, and that is science at the sea bottom, as opposed to in the water column. We do sampling within the water column, both at depth and to and from getting to depth, but the vast majority of our work is at the seafloor. We do benthic ecosystems biological sampling, we do multi-beam side scan mapping, and we do increasingly imagery. Imagery, both video and digital still pictures, is almost as important as the biological samples in many of our missions. In one case, it was the mission. Our accomplishments also include subsea geology. We not only do rock collecting at the bottom, as well as water, as well as imagery, but we occasionally have to take rocks out the hard way. And we've come a long way from using chipping hammers. We have drills and other tools, and we can in fact take cores of up to 0.5 meter in length, approximately 10 centimeters in thickness. We have built and installed the original Venus and Neptune cabled ocean observatories for Ocean Networks Canada. Equally important, if not more so because of their size, we've also deployed the University of Washington's National Science Foundation United States funded cable ocean observatory. And in fact, this summer we're going out to do a very large mission for the University of Washington to do a major maintenance upgrade for their subsea systems. Just going to play you a short video. This is in the Neptune array off the west coast of Vancouver Island on the Neptune plate. There's us diving down to the seafloor. There's a typical installation of various instruments that are being deployed, installed, and wired together. We may be operating in these conditions between 2,000 and 3,000 meters, typically. We have to be able to do very delicate installations, as well as having strong manipulator arms that can deal with moving large amounts of material, and then at the end, getting them plugged in just right. It's fascinating when you're deployed at sea and you haven't been to one of these sites, and your acoustic navigation systems combined with differential GPS at the surface allow you to descend 3,000 meters to an object that you haven't been to before in murky water. And then as you arrive at the seafloor, there it is, 2 or 3 meters away from you. As a former naval type, that's remarkable systems technology. And those systems we've deployed typically on the US Coast Guard ship Tully on the West Coast. The manipulator arms allow people to almost thread needles. When we're doing biological sampling, we put thermometers into objects less than 1 inch in diameter, a hole measured in millimeters, and put sensors in without touching the edges of that particular biological phenomena. There was a Quirks and Quarks episode on CBC a number of years ago where the lead scientist, Sally Lays from the University of Alberta, was just gushing about this particular capability. And the reason we can do that is because, frankly, our operators have been doing science as a specialty for decades. I've talked about our people and why they're important. We do things differently than most other people with ROV scientists. We take people who are maintainers, people who are electronic engineers, mechanical engineers, electrical engineers, and we teach them how to fly robot subs. That way, you've got people working shift 24/7, 12 hours on, 12 off. If something goes wrong, the people who are flying it can do diagnostics on it, literally as you're bringing it back to the surface. And without waking people up and trying to explain what went wrong, they just fix it, test it, get it over the side again. And it means that our operational time It's a very small community of practice globally. People know that if they hire us, they're going to get uptimes in the order of high 99%. Our people are also able to operate in austere conditions. This was underscored by a mission in the Antarctic in 2017. And Russian research vessel Treshnikov, a recent build Arctic icebreaking class capable research vessel, but it was very austere. We met the ship in Hobart, Australia, and we had to deploy on the forecastle of the ship as opposed to the quarterdeck. And when we asked simple questions like, okay, well, where's the upper deck power supply? They brought us 2 decks down below, about 40 yards away from where we would have to be operating vertically, and said, there's the power conduit. And our chief engineer had to work with Australians to design, fabricate, build, install, and test a complete supply system and cabling to the upper deck in a day and a half. So we're pretty good at things. We deployed in Sea State 6, and by deploy, I mean we operate. We were putting the robot in the submarine, the robot over the side with a very specialized launch and recover system that basically has a metal on metal connection until you've got neutral buoyancy in the water, doing compensation vertically, horizontally until you're ready to go click and release it without putting any dynamic tension on the string, and recovering in the same manner. That ability to operate in marginal weather is another distinguisher of how we do business and why people from all over the world come to us for solutions. And we survived on that mission in sea states as high as Sea State 9, which are fully developed hurricanes. So if you watch the film Master and Commander, that's the weather. There is an example of us deploying in a very high sea state. And that's what the scenery looked like in the Antarctic. It's the only time we've deployed in the Antarctic. We've gone pretty well everywhere else in the world. We do very minimal maintenance during the cruise. That interferes with sea time. Sea time is expensive. We have experienced operators and very mature civilian operator staff. We are in mature systems. We do multidisciplinary dive support on the same mission. We got lots of tools. We can sample pretty well anything the scientists want. And we also have a 2-meter stainless steel chainsaw. And that's important for geological sampling. Although I believe that given the fact that that submarine deploys with 3,000 volts at the head at 600 amps, and I have a 2 meters chainsaw, I should be invited to Robot Wars, because my belief is we would clean up. I think the fix is in. When I say multidisciplinary, we can support dozens of scientists from multiple disciplines, biology, geology, etc., not only on the same deployment, but on the same dive. And we have done so successfully numerous times over the decades. We have very happy clients. I'll point out that this year alone, we're doing work for Korea, we're doing work for the National Science Foundation of the US, and we're doing work for the Germans. All these people have their own ROV systems for science indigenously. They like working with us. There's an example of some of the 2 ROVs we supported for the University of Laval. This deploys in the Arctic icebreaker research vessel called the Amundsen, operated by the Coast Guard. And it deploys through what they call a moon pool, which is a big hole in the center of the ship. And that way the ship can operate in the ice, but you put it down through the ship so you don't have ice chunks breaking that expensive string. If it's going to fit through a hole in the ship, it's a small submersible. Instead of having a 2-ton payload, this one has a 60-kilogram payload. And it has tiny little Tyrannosaurus Rex arms as opposed to something big and substantive. On the other hand, it's the only science ROV working in the Canadian Arctic on a routine basis. But occasionally we don't do science, we do search and recovery. And that is an interesting challenge. The first one predates ROPOS in that this was the Pisces 4-man submersible that was operated by our general manager, Keith Shepard, and Bob Holland, who retired a few years ago. There was a CF-18 that crashed from high altitude off the west coast of Vancouver Island in clear sky, killing the pilot. Interestingly enough, there was a previous crash of a CF-18 at Brooks Peninsula, but that was somebody flying low, slow in a hurricane force winds and not mountainous, cliff-like environments. And we know exactly where and what happened to that one. But the one that fell out of the sky 2 years later, they really wanted to understand what happened because they had no radio reports, no signs of distress. It just went flunk. So the RCN was tasked to recover the black box, but the Coast Guard ship Tully and the Geological Survey went out immediately to search with side scan sonars. And then when they found a wreckage field, they put pinger buoys at the top of it so we would be able to dive on it. HMCS Cormorant, at that time, the East Coast Naval Diving Support Ship, which was also removed from program review from the naval inventory because of, well, the government was going bankrupt and they had to cut a couple of things here and there. And they used the DFO Science Pisces 4-man submersible that was stationed in Victoria at the time to embark in the ship and then deploy. The aircraft crashed on the 22nd of April. We started looking for it in June, but we knew where the bits were. So that's what Cormorant looked like. I'm old enough to remember what she looked like. I've never sailed in her. It was basically a converted civilian vessel. And Pisces 4 sitting over the stern. Now, Pisces 4 predates the CSSF. I've told you about who was driving it. There was also a Captain Barnes from the RCAF on every dive. Bob Holland's got really good stories. He was in Pisces 5 operating off the east coast of Canada when Pisces 3 off Ireland sank, broke the cables and trapped 3 men on board. And they had about 2.5 days of CO2 scrubbers. And so there was a Hercules aircraft spun up from the RCAF. It deployed from, I believe, Shearwater to Ireland. It transported the Pisces and a bunch of other equipments and the people. And they managed to get Pisces 4 off the Pisces 3 off the bottom with no air left, no oxygen left, no CO2 scrubber capability. The people were just about dead. Anyway, back to the CF-18. It took us about a week. We found the black box and other things, including the airspeed indicator and the controllers. As a souvenir, we have the titanium housing for that black box in the maintenance area of the CSSF here at Sydney, BC. We do collect souvenirs. There were 10 dives. Sorry, there was numerous dives up to 10 hours. We found the site quickly because of the pinger, but there was incredible amounts of very dangerous debris fields, wire entanglements. It was relatively shallow at only 700 meters. They eventually found the flight recorder in a mass of wires. It was a routine operation for us, just a long one and a comfortable one. So many years later, the Queen of the North sank. It is in waters that I have sailed many times in various vessels, including that one up there, HMCS Yellowknife. It's very simple navigation. You got steep fjord-like sides, left and right, port, starboard. And when you come down to this particular place, you make a left-hand turn before you smack into the cliff. The ferry didn't make the turn on time. And at the time of the grounding, which was really almost smashing into a brick wall, they were 1 kilometer away from where they should have been on course. And there was no evidence of alterations of course and speed at any time during the transit of that particular sound. Human negligence was quickly zeroed in as the cause of sinking. In the hour it took to sink, passengers got into their lifeboats and were soon recovered, except for 2. The Joint Rescue Coordination Center tasked 5 Coast Guard ships eventually and 2 RCAF helicopters and 1 Buffalo for top cover flight surveillance. But the First Nations recreational, but primarily small fishing vessels from a nearby bay were on scene first, and they were the ones that were picking up people in the dead of the night. If that had happened elsewhere, there would not have been that help coming in such a short period of time. Oh, yes, back to that. If you're talking informally to persons in the National Transportation Safety Board, it was an elderly couple that was missing and people were wondering whether or not they stumbled ashore. But based on detailed reconstruction of where everybody was from the bang to the time they got off the ship, and then going through all the ship's diagrams, there's a belief that the 2 people went into an elevator right at the onset and then they lost power, which is a sad way to go. So we had an urgent requirement. They had attempted to contract with another party. I won't mention them, but they weren't able to handle the job. So public service comes to us and says, here, you do it. And it was a fascinating contract. It was basically all your costs plus a margin. Give us your receipts. Okay, so we charter a barge, we do this, we contract in on our people in our usual roster of talent. No haggling on the contract. It's just like, here you go. We take a very patient approach to solving and testing and building, designing and fabricating. That all went out the window. This was just improvise, adapt, overcome. Need to get a camera inside the bridge wing. Okay, get a long stick. Gun tape it on, duct tape or whatever, and put it inside. Basically, the goal was to see in every bridge window, hold doors open, pan and tilt until you found what you were looking for. We hastily built a battering ram. It worked for a while, and then the one window didn't break, and it turned out it had been recently replaced, and it was a much tougher window. Okay, so we went down with a sledgehammer, and we got some fantastic videotapes of doing a break and entering on the bridge with a sledgehammer. It looks a little bit like Thor's hammer from the movie. It's also on display down at the maintenance area of this facility, along with a baggie of smashed windows debris. We like to collect things at the seafloor. That was what ROPOS looked at back then for that mission. Eventually, we got the hard drive of the PC by dragging the whole computer out. That was the navigational computer on the bridge. Wasn't quite the same as an aircraft black box. And we used a boat hook. Again, you tape it to one of the manipulator arms. You've broken the window. You've identified with the cameras where it is, what it is you're looking for. And then the robot puts an arm in and then gaffs through one of the ventilation slits in the side of the computer box, twists, and ripped out the computer. And the hard drive was hermetically sealed, and it survived the 400-meter depth. They were able to get all the data off of it, and the information on that sealed the case. The officer was convicted of 2 counts of criminal negligence causing death and sentenced to 4 years. I think he got off lightly. So the most recent episode was almost a decade ago, and that was one of the Messerschmitt Coast Guard helicopters operating off the Amundsen. We weren't in the Amundsen at the time. The little ROV was broken, and our people were elsewhere, so they weren't doing any dives that summer. So, well, they had a broken ROV, no crew on board, and the helicopter went missing. It crashed about 600 kilometers west of Resolute. There were a number of people killed, and a search and rescue expedition was conducted almost immediately after search and recovery. The helicopter had only been about 5 kilometers from Amundsen. They radioed that they were working. There was no final response to the call, and whatever happened occurred quickly. And the helo's front end, at retrospect, was heavily damaged and the tail broken up, and the debris field was strewn 300 meters around the aircraft. This was determined later. The pop-up floats were activated, but they were not deployed. That was due to mechanical stress as a result of the crash, probably. Our staff were contacted by the Coast Guard immediately, and we were in fact in a research vessel off the west coast of Vancouver Island with ROPOS doing another mission. But it's late September, and it's getting dark in the Arctic, and the ice is closing in from all around. 2 of our staff left the Falkor by seaboat at Banfield, and they proceeded to Nanaimo Cassidy Airport, to YVR, to Edmonton, to Yellowknife, to Resolute in a series of aircraft, taking 20 hours to get to the Amundsen, which was heading straight for Resolute. In addition, we were ordering little bits and widgets from various marine shops to what we knew was going to be needed to fix that helicopter, to fix the ROV in order to find the helicopter. And it was joining the various flights on the way to the north. These people had been at sea doing 12 hours on, 12 hours off sustained operations. They're spending the better part of 24 hours to get to the Resolute. They did an over-the-beach transfer in a rubber boat, and then they proceeded to sea, not to get caught up on their sleep, but to fix the ROV. So there was a total of 5 dives on site. And by the time they got to the dive site, they had the ROV fixed. And the work they did in a day and a half without sleep were basically new thrusters for 2 of them. The rest were fixed. They had to open up and install new navigation systems and other stuff. And they also put in a recovery hook in case it was needed for something, which it wasn't. They narrowed the location of the helicopter using a hydrophone, but the real interesting stuff was before then. The navigation team of the ship managed to figure out where they thought the helicopter was based on a click that was on the audio tape of the frequency that they were operating with the ship and the aircraft. And they did a dead reckoning calculation that if that click was associated with where the helicopter came down, that they would probably find that's where the ship, that's where it was. There was a timestamp, and they were right in terms of where they were looking for it. The search for the helicopter, they were out. They found 1 small piece of debris on the left-hand side, and then very quickly found another one. Then they found a door and parts, and then the wreckage. I don't know what it looks like on your screen, the image on the right, but the image of the right was the first image of the helicopter at depth when they came up upon it. And that's an amazing feat for the first dive based on a dead reckoning position in the Arctic at several hundred meters of depth. And the ice is closing around the ship. There's a screenshot. Bigger ice floes were getting close. The Coast Guard ship Larsen was basically circling continuously the Amundsen to try and allow the ship to hold its position over the wreckage. It was getting very difficult. The decision was made to try and recover the ROV, to recover by the ROV based on the desire of the Transportation Safety Board and the Coast Guard aviation people. They wanted to know why the helicopter went down. The problem is that that helicopter is a long way from the 60 kilogram load capability of that tiny ROV. Now, they had a bunch of scientists on board that were experts at putting moorings in the Arctic that would remain over the winter, collecting physical oceanographic and chemical data on the sea conditions around them at various depths. And they would deploy these with a big metal anchor, which was a railway wheel from a salvage yard, chains, cables, and various instruments on floats that would float up in the water column. And if they had an ice floe go over them, they would just be knocked down and then they'd float back up again. So what they did is they looked at all the inventory they have and they put together this. What you see in that picture is a barrel with a long string in it and a float that's got a lock on top of it. Now, you can't lower that to the seafloor when our ROV is operating because 2 cables in the water, 2 strings, behave totally differently because they're loaded differently, they're made of different material, and inevitably, over the hundreds of meters of the water column, they will get strung into a knot. So what we did is we got the ROV in the ship, and then they carefully, after building this thing, after having designed it, forget about the testing, they actually lowered it to the seafloor within a couple of meters of the helicopter, which is pretty darn good seamanship. Then in that, we use acoustic releases because when you deploy these on the seafloor, typically, okay, well, we now want to deploy the float to the surface or near the surface with all the instruments on it. So what they do first of all is they hit an acoustic release, which a sound signal sends something to say, blow up that little piece of bomb. And then that cuts the cable and you bring the cable in. And then you're ready to set out the float. You hit another acoustic release with a different acoustic signature and it blows away the top cover and the float comes off to the surface. It sounds simple. They put that whole thing together right on the top out of necessity. They also had to design and fabricate a webbing harness to attach everything to the helicopter so that the robot submarine would go down after they hit the first acoustic release and hauled the cable that lowered it to the seafloor away. And then we lowered the submarine. And then the submarine goes in there and takes all the material out and then ties the the little robot arms, tie the webbing around the helicopter struts so that it's going to be anchored onto the floats at the other end of the string. An amazing job. That dive took 4 hours. It was about 460 meters. After they did all the work doing the rigging, we recovered the ROV, and then they hit the second acoustic detonator, and the mooring float was released to the surface. And shortly after that, the float was spotted, just as it was being swept over by an ice floe. The ship moved towards it at speed, and they deployed a fast rigid hull inflatable boat, and it came up behind the ice float as it went away, and it popped, the acoustic float back popped up, and there was more debris, ice coming in behind them. The ship managed to hook up to it and then put it to a heavy duty winch, and they very slowly recovered. Already fuel was showing up on the surface from the debris field, and then they were finally able to see the helicopter. And that's what it looked like on the upper deck. In 12 hours, they had deployed the mooring, rigged it, and recovered the helicopter. The crew were speechless. So that was the team that did it. They all get credit. 2 of our staff are there. The vast majority are people from the science community and the Coast Guard. Jonathan Lee, when I came into the CSSF a few years ago as president, he came up to me one day and said, "You're in the military, you know what medals are?" And I said, "Yes, what's this?" And he handed me what I've never seen before, but had seen pictures of, and it was the Coast Guard Commissioner's Medal. It's the CDS, it's basically the CDS commendation for the Coast Guard Commission. And I said, "What did you get this for?" So Jonathan told me this story, and I said, "Cool." And then I had beer with Vince. He lives in Halifax a couple of years later, and got the same story from him and put the story together for presentations like this. He asked me what it's for, and I said, honors and awards typically come from Her Majesty. And so they actually have to go to a place in Ottawa to get vetted, and then they have to go off to Buckingham Palace. Well, most of the vetting happens here in Ottawa, but it's not controlled by the Coast Guard. It's controlled by another organization. It's honors and awards. So you got the highest award the Coast Guard Commissioner can give you. And he went, "Really?" I said, "Yeah. Whatever you did, it was pretty good work." Anyway, so enough about search and recovery. I want to talk about something that's important to me, and that's the Arctic and Offshore Patrol Ships and science. Some of you may be aware that the Coast Guard fleet has fallen apart in the last decade. The 60-year-old Hudson, the premier flagship for science for Canada in our oceans, they finally gave up on trying to fix it. It went into a refit in 2016, and they spent 6 years and probably close to $750 million trying to get that ship back to sea again, and failed. It's 60 years old. Retire it. There's no replacements. The Needler, the Templeman, they're gone. It's very similar to the sad story of the RCN, but there are no replacements yet. They're just beginning to come off the assembly line, decades too late, and no one-for-one replacement, and the capabilities aren't what we need. And the problem is accelerated to the point where in the Atlantic Ocean, we have no viable research vessels for government science or academia. In order to do essential fisheries monitoring this last summer, we had to contract to the Americans and to the and an Irish ship. And demand for ocean science globally has been increasing for various reasons. In Canada, we have a requirement now to do monitoring of marine protected areas. We've greatly increased the number of marine protected areas at a time when we don't know if we're doing a good job of protecting them at all. However, the Navy is taking delivery of 6 ice-capable Arctic and offshore patrol ships. And then after they come, then the Coast Guard gets 2 more of their own. That's a big fleet. The question is, they're not built for science. They're built, though, to be able to do science. So they're supposed to conduct seaborne surveillance, gather intelligence, and cooperate with other government departments in carrying out their mandates. And that includes the mandates of DFO, NRCan, and what we used to call Industry Canada, which is what looks after things like academic research funding. They have a mandate for doing ocean science. Therefore, it's a mission for the ships. That's what they look like. They're basically a 6,600-ton steel box with one tiny little gun on the forecastle and lots of space, lots of power, lots of cranes, and hard points for 20-foot sea containers. And increasingly, there's that 20-foot sea containers is what we use to move around our robot submarine. We have about 5 Lego building blocks. So one of them is an operations center. One of them is a workshop. A 40-foot sea container, which we won't take to sea on a ship, is how we move our launch and recovery system. We can take a barge and turn it into a world-class research vessel, which is what we did for the Queen of the North. We can certainly take a ship like this and do world-class science. In addition, they have 50 spare bunks. One of the constraints of research ships is you never have enough bunks in order to take all the people to sea you want to, including graduate students and undergraduates. These would be unprecedented ability to take large groups of researchers to sea in the Canadian ocean science history. So we're in early stage conversations. The first AOPS, Harry DeWolf, went operational about 4 months ago. We hope to get to sea as early as 2024. We had been hoping to get to sea in 2023 with the AOPS, but the Navy's busy right now trying to figure out how to put ships in waters close to the Ukraine, among other things. So in conclusion for this talk, we are a science-focused capability, but if something happens, Canada needs something for seabed intervention, we're ready. The last time that happened was HMCS Yellowknife again. She happened to have a Hugin autonomous underwater vehicle on board for mine countermeasures trials and exercises with RIMPAC. And somebody thought they had found an atomic weapon from a B-36 that had crashed many decades ago. And so they had to deploy with their crew, and they found the object, and it turned out to be a boiler from a paddle wheeler of all things, not that missing A-bomb. Who knows where it is? And we are going to need the AOPS if we have a chance of going back to do ocean science at sea again for the next 10 or 15 years. So time to go back to sea again. We have a lot of great staff. We've also had a lot of government support, both direct funding and for users. And I'm here to answer questions. And yes, that's me on the upper deck with the beast. Same sweater.
Thanks a lot for that, Doug. That was a super presentation. It's also a great hero photo. What's the story behind that photo?
I was out in the Tully doing a mission for Ocean Networks Canada, and we had embarked a guy called Ed from the Puget Sound, who is the best underwater videographer on collator of information, including real-time feeds to hundreds of thousands of people at one time on Twitter and Facebook and things like that. And in a spare moment, I said, I haven't got a picture of me in the robot sub. And he said, okay, I'll figure this one out. And he sort of paced around, put me on the upper deck and said, okay, stand here. Now, I want you to get in your mind that you are Wyatt Earp. You just come back from the hills for 3 weeks chasing Jesse James and the entire gang. They're all dead or captured. You're going into the saloon for your first whiskey in almost a month. And I turn around with my big primitive camera and say, I need a picture. That's your pose. And I went, okay. And that's the pose. And the picture turned out rather well.
Yeah, it does. No, it looks great. And so following up on this, what was the longest mission on the sea floor that you have ever conducted in a single dive? And what were the science questions behind that single dive?
That is a very good question. You go up and down in an elevator, as it were, that's dead time. So you try and stay on the bottom as long as you can at one time. You're usually limited by your weight and tonnage about how many, sampling, for example. Typically, you're down there for about 6 or 8 hours. On one mission in the Central Pacific, on the western side, we were down for 96 hours on the seafloor. And it was the most boring mission we've ever done. That seafloor had been mapped to almost millimeter resolution by multi-beam sonars. And they wanted the photographs of the overlay of that they're going to turn into a high resolution 3-dimensional file that people can put on helmets and walk around in a school gymnasium, and they're walking along the seafloor. And it was an active volcanic and hydrothermal vent. So they've got all these smokers and weird biological and geological phenomena. But to do this, we had to buy a camera, and we blew the warranty on the camera because it was only warranted to 100,000 images, and we went through a couple 100,000 on the dive. And we would precisely position the camera on our belly about 1 meter off the seafloor and take a picture, and then precisely move it approximately 1 meter away and take another picture, and then another picture, and basically just do the whole jigsaw puzzle. So we've got one collage, as it were, of the whole seafloor that is rendered into a 3-dimensional image for school kids and researchers just to wander around and go, ooh, look at that. Yes, the longest and most boring mission in our history.
Okay, I want to expand a little bit and sort of explore the capabilities of ROPOS a little bit more. So I'm going to give you an example here. As on the 10th of April in 1963, the USS Thresher, the United States Navy nuclear submarine, was lost with all hands during a deep diving test after a refit. Now, the wreck currently sits at a depth of 2,600 meters, and the loss of the 129 souls on board, both crew and shipyard workers, still holds the record for the greatest loss of life of any submarine disaster. Now, given that the wreck is a grave site, if you were asked by the United States Navy to send ROPOS down to the Thresher wreck site, what could ROPOS offer in viewing that wreck and perhaps contributing to determining why the USS Thresher was lost?
Because submarine hulls, if they're largely intact, are strong, we would probably be incapable of doing anything other than working the debris field, assuming there is one, and then bringing things back up to the surface. We would work with the USN authorities very carefully and diligently. They would be monitoring everything we're doing in real time on the surface. We have tremendous bandwidth down the fiber optic cable. In our control panel, you see all the cameras, and there are about a dozen of them in every direction. And so there will be interactive. What's that over there? Can we go over there and look at it? Can you put that in a, for lack of a better word, a bin that we'll bring down on our belly and drop on the bottom, and then just do sampling and bring the stuff in there. And in addition, we can fly through the water column, taking chemistry measurements and sampling, both not only taking samples of the water to bring to the surface for analysis, but Peter Gerges at Harvard built an in situ mass spectrometer. And we deployed that for him on one research cruise. And that allows us to go through the water and looking at not only the real-time chemistry, but also the radionuclide chemistry. And those sorts of things would be very interesting, likely be very interesting to the United States naval authorities. What we don't have, even with our rock drill, is something that would be able to do routine piercing the hull or something like that. So it would be very limited to just doing sampling around the edges, as it were, as opposed to anything inside the submarine. It's only, I think you mentioned it was about 3,000 meters or less?
At 2,600 meters.
Yeah, we've gone down to 5,000. In more recent times, we've typically operated up down to about 4,200 meters. So that wouldn't be a challenge unless there were high currents. Because we travel relatively slowly down at the bottom, if you're in currents or water of more than 2.5 knots, we would not be able to operate safely.
Okay, thanks for that.
Can I just use this for a second?
Yeah.
We have a problem when a submarine has a problem in Canada in the RCN. And it's on the bottom. It's a subsmash, and we do not have capability in Canada to deal with that. We have to sort of sit around and call for a NATO intervention or an American US Navy intervention. If we had a Canadian sub in Canadian waters on the bottom and needing help, this system, particularly if we could deploy into an AOPS, would provide an ability to put CO2 scrubbers and oxygen through the torpedo tubes, which is the normal process for getting things in and out of a submarine on the bottom. We'd be able to go down there and knock on the door, and listen carefully, listening for, signs of life and things like that. But if you needed an urgent intervention on the seabed for the RCN or other government requirements, that's one of the ones where we can do things on the bottom that could help. And I would be delighted to be in an AOPS ships doing a sub-smash exercise by 2024.
Okay, thanks for that. At the start of your presentation, you mentioned something called an AUV, and it went by me pretty quick. So what exactly is an AUV, and what are the differences in capability between an ROV like ROPOS and an AUV?
It should be pointed out that the Defense Research Establishment Pacific was a pioneer in autonomous underwater vehicles. They deployed a robot submarine, but an AUV doesn't have a string. So you put the robot submarine in the water and it goes away, does its mission and comes back pre-programmed. They have put robots under the Arctic ice in the late 1970s and early 80s for days at a time, practicing how to lay fiber optic cables under the ice for systems for detecting submarines. Back in those days, computers on board a robot submarine were basically steam-driven abaci compared to what you can get on a smartphone these days. Something like that, which has more power than a Cray 2 supercomputer had in that time of the year, that time. So you take away the string, you take away the real-time command and control, so they don't have manipulator arms. They tend to do a lot of seabed mapping, seabed photography, in situ chemistry. They're very complementary. Increasingly, research is being done by a ship that sends out an AUV and then also sends out an ROV, and they're both doing different things, but they can support each other. The AUV maps out an area and goes, well, that's different. So you send the ROV out to sample it.
Okay, no, that makes sense. Thank you. Now, suppose a commercial enterprise wanted to hire ROPOS to dive on the wreck of the Titanic. Would ROPOS be able to do that? Now, the wreckage of the Titanic is a little farther down than the Thresher. It sits at a depth of 3,800 meters. But the wreck, and you talked about currents as well, the wreck is affected by what is known as the Western Boundary Undercurrent, which is the fastest ocean current in the world, with a speed of between 3.5 and 5 knots. What could ROPOS do or offer for viewing the wreck, and perhaps even the ability of placing a commemorative plaque on the Titanic's deck to commemorate all those who were lost on her maiden voyage on the 15th of April, 1912? What could ROPOS do in that case?
Simply put, it would be a risk. We only have one submarine, even though it's insured. Trying to go down to a high bottom current environment has no benefit for our company. We're not for profit. That would be simply competing with private sector salvage capability. If there was a Canadian company that was able to do the job and we went after it, they'd probably complain to the CRA about what's this not-for-profit thing over here directly competing with us. So my board chair would probably be asking me the hard questions about why are you doing risky things that threaten the tax status of this not-for-profit that's supposed to be about science? And my board chair is the Dean of Science of Memorial University of Newfoundland. He'd probably be on me pretty fast. And seeing he chairs the one thing that can fire me, I'd probably not do this.
Okay, thanks for that. When we were talking earlier today in preparation for the webinar and before the start, you mentioned that ROPOS was also involved in the discovery of what the Americans called during World War II, a consolidated PBY Catalina, or what the RCAF called a CANSO. What's that story?
We had just come out of a major refit, probably close to about 2000. And we had scheduled a week of trials in Tully. And after about a day and a half, everything was working. The refit had gone well. And so we were just stooging around. And all of a sudden they're looking on the imagery. This predates my time in the company. And they're looking down and went, hey, there's an airplane down here. and it was a relatively intact canso. And so with the help of the Air Museum and a few other people like Bob who were inquisitive, they determined that it went down during the Second World War on landing. And interestingly enough, the cause of the landing was very similar to the phenomena that brought down the helicopter in the Arctic. When you're dealing with a very flat sea state and you're making an approach from the air, it's very difficult with your naked eyeball to determine or estimate how far you are above the sea level. And altimeters, well, in the Arctic, altimeters aren't worth anything because you've got no reference station of a nearby airport to set them by. And so in the Arctic, the helicopter was flying at about 140 knots, and they thought they might have been 10 meters off the sea, and they weren't. And when it did a little dipsy doodle, which they do as the wind patterns change or not, its skids caught, and it just, the helicopter just basically did a 90-degree turn and went straight down, probably on the order of a 40 G deceleration. Same thing on the Canso. The Canso is doing its approach to a landing on the water, but it's still well above landing speed or above, very much above stall speed. And then it touched the water and it broke apart. Well, it went into the water quickly. And the crew, which was on the order of a dozen people, over half of them were killed. And the rest were severely injured. Those who survived had life-threatening changes. A complete crew was gone. And it was attributed to the flat landing inexperienced pilots in terms of the inquiry that was done.
And where was that?
Immediately, if you know where the seaplane landing strip is, adjacent to the Coast Guard jetty well, imagine the runway for YYJ extending out into the ocean about halfway across.
So just up off of Victoria International Airport, basically.
Yeah, to the west.
Okay. And off of the actual little Pat Bay. Yeah, where there was a seaplane base during the Second World War. Yeah, okay. Before we go to audience questions, do you have any final comments regarding ROPOS and the Canadian Scientific Submersible Facility that you'd like to pass on to the audience?
I'm just the suit. I
don't see a tie.
Oh, I put it on whenever there's money on the table. No, it's in all seriousness. I won't say I'm merely the figurehead, but the technical team on there, and in particular people like Keith Shepard, who is our general manager, who's been doing this for over 35 years. They're the best in the world at what they do. And so what we have is a global capability that no one's ever heard about in Greater Victoria. But we have legions of fans that are the niche people in ocean science all over the planet. And I mean, we've done work for Tongji University in Shanghai, in the Indian Ocean and elsewhere. We've gone, they are an amazing group of people. I'll just leave it there.
Okay, that's good. We've got a couple of questions from the audience. And the first one is from John. And he asks, difficult question, I think, but how would you prioritize the needs of the Navy, the Coast Guard, and scientific research vessels over the next 10 or more years?
Well, I don't know what your background is, John, but I'm going to be brutally honest because I can be. I'm retired. The National Shipbuilding Strategy for Canada failed. It's been in place for, I guess, around 2012 to 2014. It's delivering ships at 4 to 7 times the price per hull that the South Koreans will cheerfully sell to the Royal Navy, for example, in the case of tankers. It's producing ships far too late in the game. It's the fault of Canadians who vote in all governments, this is not a partisan issue, they fail. And I don't know what the solution is. We have to be very good at fully exploiting the resources that are being delivered and to exploit them for a whole of government approach. The AOPS are ships that the Royal Canadian Navy never wanted, but they've been delivered. Parliament has voted on it. They voted money into the fiscal framework. and they're being built, and the contracts are in place. So therefore, we have to get the best mileage out of them as we can. The Kingston class ships that were delivered, they were pretty expensive for what we got. They weren't a lot of war fighting capability. They had some mine countermeasures capability that were never fully exploited, but they were workhorses and have been workhorses for over 20 years out of necessity. So we're going to have to work with what we've got. We're going to have to be nimble and adapt other abilities. For the ocean science, modularization of ocean science research components and then deploying them at sea in research vessels or in non-research vessels of opportunity like AOPS or commercial ships just chartered for that particular mission. John, does that answer your question?
Well, actually, John's got another question. How much potential is there for the ROPOS organizational model? In other words, you've got one employee plus, contractors that you use as required. And are there any other groups operating under that model as well that you're aware of?
Well, we have people like ocean floor geophysics based in the lower mainland who operate AUVs. Now that's strictly a commercial operation. We had partnered up with them to do a mission for the Koreans where he would get an AUV, not one of his, but one of the ones that was unfortunately in Singapore, and they would do the ocean mapping portion of the mission while we would use ROPOS for the sampling. We ended up in a situation where they weren't confident that they'd get it out of Singapore because of the shutdown of the Chinese lockdowns, right? So there are for-profit and there are not-for-profit models out there. This worked for ocean science because of the people, not necessarily because of the governance structure.
Right. Okay, you don't happen to have some photographs or anything of that Canso wreck, do you?
I could try pulling it up while we're talking about other questions.
Well, we don't have any other questions right now, but I thought if you had some slides on the Canso thing or not, we could have a look at that. Might be of interest.
Give me a second.
Okay.
So, can you see that?
No, don't see anything.
Okay.
It's not that critical if it's going to be awkward to find them.
Just bear with me. I'm getting better at this.
Okay.
How'd that work?
That's the basic Canso slide, but I thought you had some photographs of the Canso. There it is. I think that's the wreck on the bottom, is it not?
That's the first. That was the first picture from the mission.
Yep.
There's another one.
Yep. There's another one. This looks like part of the wing or something. And there's the plane or a similar one.
That's a similar plane.
Yeah.
And here's the investigation report.
Yeah.
Or page of it. And there's the butcher's bill.
Yeah. So 3 killed, 1 dangerously injured, 1 missing. We presume later discovered killed, and 3 severely injured. So we're probably talking life-threatening for dangerously and life-altering for severely, I would think. So rather tragic and unfortunate. There it is, Patricia Bay, Pat Bay, BC. Looks like February 1945 or December 1945, one of the two. So,
well, December 45 would not have been during the war, so I'm guessing February.
Yeah, probably. So, yeah, that would make, well, it would make sense in the order, but you don't always know about the date organization.
No,
but yes. I don't have any more questions from the audience. But so I think we can probably wrap it up. But I want to thank you, Doug, for an excellent presentation on the Canadian Scientific Submersible Facility and about what science can accomplish, specifically with the example of ROPOS, an ROV, but you also discussed AUVs, etc. So your presentation certainly highlights the need to continue ocean science and research, and also, interestingly enough, the possible future involvement of the Royal Canadian Navy's latest class of ships, AOPS. So again, many thanks again for your time and effort in putting this all together, Doug. Cheers, and thank you very much.
A pleasure. Thank you.
So we'll let it go at that. And you and I will be talking shortly. So thank you very much, Doug.
Okay.
Have a good day, and we'll get together for lunch.
Looking forward to it. Thanks again.
Yeah, thank you.